Hello everyone, welcome back to another video, Phoenix DB. This is the second part of the development vlog. So in my first video, I was kind of complaining about how making databases is hard, and then I solved my problem. So that's fun. So you guys can check out the repository here. All the source code is open source and free to use however you like, MIT license, of course. But yeah, let's get right into it. So in my last video, I um oh yeah, I'm using Rust Rover by the way. I really like it. It just works really great with Rust, and I do like IntelliJ IDEs. So yeah, I just thought I'd point that out. But yeah, so in my last video, I was mainly complaining about how I'm building a protocol, right? So if you're writing a database or really any kind of software or library, I guess, that you want people to use, it's really easy to write it in your language. But something like a database, you either have two options. You make the protocol in something like C, where many languages can use the C API to interface with the protocol or the API for your library without having to, you know, like SQLite. Think of SQLite, right? Like when you use SQLite in JavaScript, you're really calling the C functions under the hood, right? So you can do that, or you can do with many databases do and write a network layer for the database. And this way, as long as some, source or some code interacts with the library, the network, then they can use the database regardless of what language they're in. So that's what I chose to do. That's similar to what Redis does, right? It just makes everything easier. But to do that, you have to have a protocol that the network understands, right? And so originally, I was just using unformatted data. I was sort of having like query strings. I would have the command and then the values. You know how SQL does, right? It's like insert into um, you know, people, and then you have like the values and then their data, right? So like SQL, the parser will actually parse all that, but I didn't want to build a parser. So there we go. Yeah, I didn't want to build a parser or anything. So I decided just to use JSON, and I have this Python code right here, which is basically my test script. It makes it really easy. Although I'm kind of a JavaScript guy, Python having socket and JSON built in, it's really helpful. No random npm libraries. Anyways, I've been yapping, so let me get to the code, right? So here's the server. Um, I can actually start the server up. Let me actually open the terminal up real quick. Let's just do cargo run, right? And then, okay, actually, I'm going to use this terminal. Start the server, and then we can actually run the Python code, right? So let's do Python. And then I believe this is test slash basic py. And if I run that, you can see we get this output. So first we connect to the server, right? And we get the port. And then we are testing the insert commands, right? So here's what the server replies to, right? We get back a response, and it is a JSON object, which has an action, a value, and an error, right? And so we run this multiple times for many different values, which I'll show you guys. And then we test the lookup command, which fetches data, right? So we get an action, we get a command back, the value, which string value, and then this is some numbers, and this is a float, and this is an array, and this is an object, and there's no errors, right? And then we delete all those values, which returns okay. And then we look up again for the same keys, and we get none, right? No errors or no value, right? So that's pretty simple. And in the server side, you can see we have client connected, and here's the port it connected at, and then it disconnected after all the commands were ran, right? So how this works is whenever a command is ran, we send this object, right? Or structure. We send the name of the command, which is the insert in this case, the key, and then value, right? And we do the same for those. And then, obviously we don't need a value when looking up data, so that's just none, right? And same with delete. And then here we just parse the JSON and we return it, which would just be a dictionary, right? Um, Strings with second value can be anything. So I like having type support. Well, Python doesn't really have types, but it kind of does, I guess, at this point if you have a good editor. So that's why this dictionary is here. Um, Yeah, so the send command, we basically pass a reference to the socket. So originally in my older test, I connected and disconnected from the client on each command, but then I realized that you should be connecting once to the server and then just sending multiple requests using the same socket pointer, right? So we are, yeah, so what we do is after we parse the response from the server, we, what do we do? What do we do? What do we do? Yeah, right. So this function right here basically builds out the command JSON, and then we send it, we turn it back into JSON, and then we send it to the server to reply, right? Sorry, we send it to the server so that the server can process the command. There we go. And then we get the response, and then we simply print the response, which is why you see server response right here, right? And then we handle any exceptions needed. And so here's the code, basically, a try with exceptions. We basically, you know, send the command and blah, 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 right? So that's how that code works. I think this is a good model so far. Definitely a big improvement from the first video. And I think JSON, it just makes everything easy, right? Like most languages, Python, JavaScript, Java, like it'll be really easy for me to build clients for this database. Since JSON is a well understood standard. And it's probably not the most size efficient and most performant way of sending data over the network, but I'm a solo developer and this is all a learning experiment. So, you know, it is what it is. But let's get into the code. So I still have not written the CLI and everything's still hard coded. But as you can see, we just have this handle stream function and then we loop over and send all the data through the channels on the connection, right? So we have a thread and then a loop to handle the server, right? So let's go into the stream. So the stream changed a bit. So first we are actually checking the client address just to have a little, log. Like I said, in the future when I add logging, this will be kind of persisted probably in a file. And I do want to have like maybe a configuration.toml file that the database can look for in the directory it started in like the exe, so that you know, it can give more custom options. But right now I want to keep everything as simple as possible. So we have a buffer. And then we have this loop right here. Now, I'm actually thinking that this loop is not actually necessary because we're already looping right here. So I don't actually think I should be looping. Um, yeah, I don't think I have to loop over and over. Um, um, I'll fix that later. I think I'm gonna remove that loop though. But anyways, um, yeah, so we're reading the buffer like normal, right? And if there's size is 0, then the client is connected. And basically, what we're doing though is every time a request is sent to the server, Serde is creating a Rust struct from the buffer bytes sent over the network, right? And when we do that, we get the type safety of the net command, right? Net command is a structure that the database always expects to read from, right? And if this buffer does not equate to net command, then it actually returns a failed to deserialize command error, right? It sends that back to the client, right? So this is the same value as we saw right here, name key value, right? So yeah, so if the command is cool, if we find the command data, we handle the command using the command handler, right? And this simply passes in the command and the database. And this handler, it grabs the key and the value, and it basically calls the function pointer on all the commands. So in the protocol here, in the map of all our commands, we have this insert, lookup, and delete function, which are called from the handler. And this makes it super simple because this way um, we can simply grab the command and then um, we can grab, wait, where is it? The code. Yeah, it's right here. Okay, right here. It's funny when you like know multiple languages, your like mindset of like how the syntax words changes. But yeah, so the command, so the function pointer right here, the command function pointer is actually being called in this match statement, right? And then this dot await basically calls that, and then this result is returned based on the return value of this command, right? So we get a net response. And a net response is always an action, value, or error, right? And so this, I came up with this idea so that later on, when the client has a result, because the thing is, like, how is the client going to know if the data returned from the server or database is an error or not? This is just an easy way, just using an enum, right? Because then we don't have to, because there are instances where um, a command returns an error, but it's not a real error, right? It's like, oh, like if you try to delete a key that doesn't exist, that's not really an error. Like it's not a fatal error. That's just a command error. So having an action is a good way to separate um having to only rely on, this error response message. Um, I don't know if that made sense, but yeah. So yeah, we have the net response though, and that's basically returned. And then if a command is unknown, then we simply return that message. And I think this is really good because, it just helps keep everything standard and sort of like we know what data to expect, right? And so this handler returns a net response, which then is caught right here, and that is turned back into a string by Serde, and then it is written to the uh, TCP buffer, right? So it's written back, and that is how the Python code parses the incoming net response, turns it back into a understood JSON object for Python, and then as you can see, where is it? Right here, response data is simply printed out. So that is how we get this string. So yeah, I think this is a really good starting point. I do plan to add more commands. Like right now, we have this delete command, um, which is simply, just remove some data and it returns okay. And then I have some insert data and then look up. So it's pretty simple code. I plan to add more. I guess the next thing I'll probably do is add some kind of TTL, like time to live functionality, so that when you insert keys in the database, um, a sort of background task is spawned for that specific key. And when that time expires, then Tokyo will delete the key, right? So I think that's probably my next thing I want to add, and that'll be pretty cool. Because I know people do like having caches that can delete data. And then yeah, we'll see. We'll see what's the next thing. So that's just a little update though. Hope you guys enjoyed the video and I'll catch you in the next one. Peace.